All right, welcome. Hopefully, I pressed the right button and everything is visible on both on LinkedIn and on YouTube. Yeah, welcome everyone. We are here to talk about right-time data pipelines for Snowflake. And let me just verify that everything works, and then we can jump straight into it. Cool, looks all good. So, welcome everyone. My name is Dani, and I'm joined by Zulf, Estuary's head of sales engineering, and I'm very excited to kick off this edition of Estuary 101, where we are going to talk about building right-time data pipelines for Snowflake. Not just real-time or batch, but right time. Both batch and real-time are great, but it's not always what a business actually needs. So the goal is, with right time, to control over when and how your data moves. Today in this session, we'll cover problems with traditional pipelines, what right time actually means in a bit more detail, how Estuary approaches it, and we are going to see an amazing demo by Zulf using Estuary and Snowflake to make it a bit more concrete. So I only have a few slides, and then we'll actually go into the practical stuff, the more interesting stuff, so stay tuned. We are going to talk about a little bit about Estuary, the platform itself, and then finally the live demo. So to not bore you all with more slides, let's look at the architecture of a traditional modern data stack. So, as most of you are data engineers or data practitioners, you have probably seen a similar architecture diagram in your career. You have multiple sources, databases, files, SAS tools, and different ingestion methods for all of these traditional ETL, ELT, CDC tools, even custom scripts in some cases. And all of this lives in separate cloud platforms, and you slap on various transformation layers as well. And at the tail end, you have different systems for dashboards, AI, and data science. So the result of all of this is a very complex batch ELT jobs, fragile CDC processes, custom glue code everywhere, and in general, a high operational overhead. But probably most importantly, you don't have any control over the timing of your data integration. You either choose slow batch or you over-engineer and go for streaming, which you might not need. So to solve these challenges, I'd like to talk just a few words about how Estuary approaches this domain. So Estuary unifies streaming and batch into one platform. It includes native real-time CDC, declarative pipelines, so it's all configuration-based, and you don't have to write your custom code. It guarantees exactly once delivery and fault tolerance as well built into the platform. It supports hybrid deployments with private data planes for the strictest enterprise requirements, and also an increasingly broad connectivity. You're able to connect hundreds of data sources to dozens of destinations. Your most popular operational databases, SAS tools like Salesforce, HubSpot, and move the data in real time or in batch into Snowflake, Redshift, or Iceberg as well. In addition to these, of course, performance matters. Estuary supports sub 100 millisecond latency with high throughput, and all with enterprise-grade uptime. So the idea is that you simplify the stack, reduce the moving parts, and thus increase control. So we're going to learn how it actually achieves that. And just to say a few words about Estuary, for those who might not know the company, it was built by the team behind Gazette, which is the open source streaming framework that powers the actual platform. Engineers who have deep roots in distributed systems and large-scale streaming worked on the product in its initial days, and throughout the years, it became a full-fledged data integration platform that today supports those hundreds of data sources that I mentioned, and also in-flight transformations in SQL or in Python. And the use cases range from simple analytical data movement to real-time AI as well. I mentioned write time a few times already, which is kind of a new term in the industry. So I created a dedicated slide for it. And in a sense, write time means that your business should be using data when it actually provides value. Historically, it's been a big trade-off between real-time data integration and batch data integration, and there was no way to actually flexibly move between the two as you needed. Write time is all about control. So you are able to ingest data in less than a second in a streaming way when you need it. But when you don't, you can just flip the switch and let the platform integrate whatever data source you want every hour, every day, with the exactly once guarantees and platform features like easy backfills and the replayability. All in your cloud, all on your cadence. That's the summary of the write time data architecture. So with that said, I'd like to hand it over to Zulf, who will talk a little bit more about the technical aspects of the platform. And Zulf, you're muted.
Thank you very much. I always keep on doing that. I never learn. But no, thank you very much, Dani. That was a great explanation. I'm loving the slide as well that explains write time data. Hopefully I can take it a bit further. So if we can move to the next slide, I'll explain Estuary's architecture. And this is very different from a lot of vendors out there. You know, Dani showed you a great example of the typical traditional landscape that we see, where there is a trade-off between, you know, doing things like change data capture and batch jobs. Sometimes it's, you know, multiple vendors. You try to stick with one vendor, but it could be multiple tools. So it can get kind of, shall we say, like spaghetti junction, depending on what those data integration needs are, right? But with Estuary, as Dani mentioned, we have, you know, streaming, change data capture, batch within a single platform. And as we'll see in the demo, which I'll try to spend a lot of time on, we'll see the options that we have for certain connectors that we may want to capture or deliver into. But let's talk about the architecture. There's three main components here: the capture, the collections, the bit in the middle, where we can also do transformations, and the materialize. So the capture, as the name suggests, it will sit there and it will look for any transactions that's committed to the database. Now, as I stated earlier on, you'll have options of when you want to capture that data. As Dani mentioned, we're all about write time. Does it want to be real time? Does it want to be batch? You'll have options in that. So let's take real time, for example. And there's benefits for having real time, especially when we talk about databases, right? So with databases, a lot of them are key to the organizational's upkeep and daily operations. Now, any downtime associated with that database could be costly for the business. So DBAs are very kind of anxious when you start putting requests to get data out of that source database, whether it be for reporting, analytics, or AI, right? So change data capture, what does that offer you? What does that give you benefits of? Firstly, we're streaming changes we're streaming data as they change, as they occur in the source, as soon as that's committed to the database. It's polling the logs, the wall in Postgres case, or the redo logs in Oracle, or the T logs within SQL Service case, right? So that's also non-intrusive to the source database because we're not actually going into the database to take change data. We may do it for the historical data that we want to move across, but that's optional. But for change data, we go straight into the log. So it's very non-intrusive on the source itself. So let's take that as an example. As soon as data is committed into the database, and written into the logs, we will capture that data, and then we'll persist it into cloud storage. And we always recommend that the cloud storage be on your environment, so you control that data. You can put your own security policies, but more importantly, your own retention policies. And I'll come back to that point about having a retention policy within collections. But also at this point, we can also perform in-streaming transformations. So we support SQLite, TypeScript, and Python to perform your transformations. This can be low-level transformations like data type changes, or high-level transformations where you might want to do some computation or merge two tables together. Now, once data is into a collection, your materialize, the last component there on the right-hand side, will continue poll for incoming transactions into the collection. So again, this is within Estuary's framework in real time. We're not waiting for files to batch up or anything like that within collections. As soon as data resides in collections, the materialize will pick that up and output that into a destination of your choice. In our case, this is going to be Snowflake. And there are options which I'll show you in Snowflake what we can do. So end to end, we can stream that data. Now, talking about write time, what we offer here is not necessarily doing real time all the way or batch all the way. As Dani mentioned, you can have control on how you want to pick up that data or how you want to deliver that data. So we spoke about real time being beneficial on technologies like Postgres databases, RDBMSs, but necessarily on the target. Once you capture that in real time, do we want to stream that into real time? Now in Snowflake, we could do. We can leverage streaming technologies within Snowflake. Majority of the time, if it's for analytics and you don't want to do necessarily real time, you can do incremental batches or micro batches. You can schedule the jobs to go target, every 15 minutes, every half an hour, every hour, whatever makes sense to you. So again, you're having control about when you want to deliver. We may want to capture in real time because there's benefits, but we may want to output that in micro batch jobs as well. So it's giving you that control about how you control that data movement. Let's move on to the next slide. So let's talk about deployment options. So we have 3 different deployment options. The public is our SaaS offering. It's where Estuary will control 2 parts of this equation, the control plane and the data plane. And just to give you a bit more visibility in what they are. The control plane is the UI that you'll log into, and you'll do your data pipe creations, you'll do your monitoring, basically managing the whole Estuary ecosystem. The next component is your data plane. And this is where data is processed. So within the SaaS framework, the public framework, Estuary controls the whole environment, including the data planes. And we have several data planes. We have data planes in several different data centers across the US and the EU as well. Now, if there was a reason whereby you may require a dedicated data plane, maybe for HIPAA compliance, regulatory compliance, maybe you want to have a dedicated data plane on the vendor of your choice or the region of your choice, then we have 2 additional options. We have the private deployment and the bring your own cloud or BYOC deployments. This is where we will give you your own dedicated data plane where data processing's done on the cloud vendor of your choice and the region of your choice. Now, the difference between private and bring your own cloud is who spins up that VPC that's going to be dedicated for your data plane. With private, that will be Estuary, so we incur the costs, but we will give you the access and grants so you can actually use that to process your data. Bring your own cloud is where you'll have their own resources. So you'll spin up, if we take AWS, for example, an empty account, we will deploy our code and we will manage that for you as Estuary, as an organization. But the resources will be your own resources. So again, all of these options, just to emphasize, is going to be a managed service where Estuary looks after it. It's whether you wanted a dedicated data plane and who spins up that data plane for you. Let's go to the next slide, please. And Dani mentioned, one of our great strengths is that we have a lot of connectors. And so I think we're around 225 connectors, definitely 200 plus different connectors. And these range across all different kind of applications. SaaS, databases is a key one, as I mentioned. There's HR applications, financial applications, marketing applications. There's a whole range. So I'd encourage you, if you're interested and you want to make sure we support you, we have a dedicated website where you can actually check connectors that we do support, and we have documentation around that so you can see what exactly Estuary supports and what's required in order to capture data from that, whether it's real time or in batch. Next slide, please. Right, let's talk about the demo, which we're going to be doing very shortly. So as part of this demo, I'm going to show you Postgres as a source. And we'll look at kind of the options that we have for Postgres as well. And we'll take that data. We've got some examples where, I'll show you some batch data that's gone through and also some change data as well. And we're going to be putting that into Snowflake. And again, showing you, emphasizing on Snowflake, what kind of options we have to support data integration into Snowflake and, why that makes sense. So without further ado, Danny, if you can stop sharing, I'll share my screen. Thank you very much. Right, share screen. Let's do, there we go. Okay, hopefully I am sharing. I can't see anything, so Danny, if I'm not, just unmute and just let me know. But I'll continue as if everything's okay. So what we have here is a Postgres source. I've just got a quick movies table. There's some existing data in there, and I'll show you, some examples of the bulk load and change data as well. I've also got a script, just a short script, just to show you some changes going through, right? And insert, update, delete as well. So this is kind of the base of my source. Now let's go and show you what Estuary looks like. So as I mentioned, there is a UI where you'll log in and you'll be introduced into your welcome screen. So from here at a high level, if you've got Estuary up and running, you'll get some high level activity about your active data pipelines, both from a source and a destination. As I mentioned earlier on the architecture slide, we have this decoupled architecture where we've got the capture that loads into collections, and then the materialize will look at incoming collections, data and collections, and put that into Snowflake. Now, what I should have mentioned actually that I did bypass is what's the benefit of having this decoupled architecture as well, right? Now, usually with other platforms, when you have requirements to add new destinations, you have to create a whole new pipeline to capture that data again from the source. As mentioned with Estuary, because we've got this decoupled architecture, we can capture that data once and we can spin to multiple targets downstream. So that's also not only efficient from a technology point of view, from your source infrastructure point of view, that we capture that data once. We also, from a cost perspective, only charge you that once from a capture point of view, and you can use that data multiple times downstream, right? So you might have a requirement a few months down the line where we're putting data into Snowflake and you say, right, we want to use Iceberg as well to create some ad hoc reports. With the retention policy that I mentioned earlier on in collections, if you have a long enough retention policy and the data resides in there, you don't have to capture that data again from the source. So you can spin up a new materialization, a new target, and just replay data from your existing collection. So again, it's saving you a lot of overhead from your source infrastructure, unlike other tools out there that would require you to spin up a new capture job. So that's double the load that's going into your source. There's no need to do that within Estuary. You can actually pick up that data from your existing collections that's in your own cloud storage and apply it to a new target as well. So this welcome screen. So let's go and look at sources. And you'll see here that I have some examples. But the first time you actually play about with Estuary, you'll need to start a new capture job or create a new capture job. And if I type in Postgres in here, it's just to give you certain examples of the different flavors of Postgres that we support. But more importantly, it's around the theme of having that right time data. Do we want to capture that data in real time, or are we okay doing this in batches? So you have options in here, and you'll notice that the recommendation we always put is real time, and that's because, as I mentioned earlier on, it's non-invasive on the source, so it's a lot more efficient to capture that data, especially when you're streaming that live in near real time. So we do have this option for real time and batch. So let's take real time as an example. What do we need to do to kick off this capture job? So first of all, we'll give this a naming convention. Now, the whole configuration is done around tenant names. So when you sign up for an account, the first thing you'll be asked is to create an organization name, which is our tenant. Anything that we create under that configuration will be stored under that tenant name. So my, for example, is Zulf-demo. Now, when creating a capture, you can give this any naming convention. We'll look at this a bit later on when we've actually created this capture job, what's actually outputted. But more importantly, come back to the data planes. Now, I'm using the SaaS version. So here's the data planes that's available to me in specific cloud vendors and cloud regions as well. Now, we're always adding to this, so this is going to expand as time goes on. But if there's, for whatever reason, that you require dedicated data plane based on the cloud vendor and region of your choice, and whether you have resources to spin that up, we can actually go down the route of private or bring your own cloud as well. And that will also show up when that's been set up in this list as well. And then from that point onwards, it's just a matter of filling in the details to connect that specific data point that you want to capture data from. Now, for Postgres purposes, we're going to have a dedicated a database user that's required for replication. We always recommend that you create a dedicated user for this purpose instead of reusing existing users itself. And there's certain privileges that you must satisfy in order to do change data capture from those sources. And each platform will have their own requirements. So, Oracle, for example, you'll have things like supplemental login. With Postgres, you'll need to set up well, actually, it goes through here that, wall level that needs to be logical, for example, and then you need to create a role with replication attributes. So each source will have their own requirements. SaaS applications as well will have their own requirements as well. And the great thing is you've got this documentation, not only in our website, but also within the UI that will, walk you step by step on what needs to be configured and how to set that up. One thing I want to pay close attention to, we've got this capability called history mode. Now, by default, we're a SaaS application. We want to save you cost as well. So when we take data from the source, we take the latest copy. And what do I mean by that? With history mode, what would happen by default with history mode is if we had a transaction that had 5 updates to the same primary key existing record, what Estuary would do by default is only take the 5th update because that's the latest image of your source database. We won't concern ourselves with the rest of the previous updates. However, for certain reasons downstream, you may want those transactions. You may be doing slowly changing dimension type 2 kind of operations where you want to create a history or audit table downstream. So for that reason, you may want to capture all 5 updates. So history mode will enable you to do that. By default, we don't. Like I said, we want to save you cost as you move data through, so we only take the latest image of your source infrastructure. So that's that one option there. And then there's also advanced options in here, and this will be specific to each technology. So if I just go back to my sources, and let's just look at one that I've got one created already, and just show you what that looks like. So once I've put in my configuration, I go to next. I've actually got history mode enabled. But what we also have is not only DML, but DDL, or schema evolution, as we call it in Estuary. So anything structurally from a table point of view, if new columns are added, if data types are changed, we will capture that by default because schema evolution is enabled here by default. Now, these are toggles, so you can switch them off if you're not concerned about this, but we also do capture DDL changes as well as DML in Postgres case. And then based on the user privileges, we'll have access to the source that we can actually peer into and take data out of. So here we have that movies table that I've got. And once you're done with that, we'll go ahead, click save and publish. And once it's published, it's actually going to do, for the first time when we run this, it's actually going to do a backfill. So that's the historical data that we have currently in that database. We're going to move that across. And once we're done, we're going to switch over to CDC, and any new changes that occurs, we're going to propagate that across. So you can see here at a quick glance, there is some metrics in here as well. So just before this webinar started, I do my quick testing and making sure data goes through okay, and we'll look at that in a minute. So just a quick glance, I can look at that. I can log into that capture job and get more information from here as well. So as I mentioned, we can see the volume of data, the number of rows that we've moved across. You can see there's 12. I'll explain that a bit later on downstream. But we've also got tabs in here to give us notifications if there's any alerts that happened. I've got one that's historical in here. Looking at the spec of this capture job. Any history, change configurations that's been done, we keep a history log in here. And we can also peer into the logs. So what's Estuary doing in real time in the background? So we got access to these logs. If there's errors, first port of call for troubleshooting, we look at the error here and seeing what's gone wrong. Okay, so that's the capture job. As I said, once we start capturing transactions, we'll put that into collections into your cloud storage. So in here, we'll create a collection for every table or resource or whatever the source is. and we will create a collection for each table. So we've got here the naming convention. So that's our tenant name. That's the name I've given my capture job. That's the schema name. So by default, we've picked up the schema name from source and the table name as well. So again, within the collections, I can also peer into and get more insights about the data that we've captured. We can also view the data in here as well. So I can see from this record, okay, we've got that record in here, ID 4. More importantly, in here as well, we've got more information about the task when it was captured, what's writing to it. So I can see the capture job that's writing to this, and I can also see the materialization job. Now, first time you create this, as we go step by step, you won't see the target. Let's take it in theory, the destination hasn't been created. But this gives you kind of like more of like a data lineage kind of information about what capture job is populating this data and what materialization job is reading this data and populating the target. Now, destinations, first time, you like the capture job, you create new, you type in the technology of choice, and again, we'll create a new materialization job. Now, I'm going to skip that part for creating a new one. We've gone through that, but I'll show you this particular capture job that's already gone ahead and created. And like the capture, you're giving this a naming convention. You're going to specify the data plane that you want to execute this against. You're going to put in your credentials. And I'll point your attention into here. So we're going to give it a database name, the schema name that we want to go across. Now, you'll remember from the capture job in Postgres, the schema was public. And I'll come back to that as well. So what I want to do in my case is typically we can do a lift and shift where we do like for like, right? So maybe on the target, you want to have a public schema. You want to mirror exactly what the source looks like. In my case, I want a different schema name. And Estuary does all the hard work for me. So as well as moving that existing data, Estuary is also going to create the target table structures for me based on the information I put in here. So it's going to be under schema demo _SC, and then it will populate the data in that table itself. Now, we spoke about history mode. I also want to talk about how we can deliver that data into Snowflake as well. So by default, what Estuary is going to do is we're going to do a soft delete. Now, for those of you that don't know what soft delete is, let me just explain that very quickly. So we will perform inserts and updates as they are. An insert will go in, an update will update that record. However, when it comes to a delete operation, we will capture that delete operation from source, but as we deliver that into Snowflake and we don't enable anything extra in here, with the delete operation in Snowflake, we won't physically delete that record. We will add additional metadata columns, things like the op type, the timestamp, and we'll just say this record was marked for deletion, but the record still exists in the source. Now, if you do want a like-for-like mirror copy of your source, hard deletes, if enabled, will physically delete that record as well on the target. So that's two options that you have here. Soft deletes by default, hard deletes if you want a mirror copy. And I'm going to take that a bit further in the next couple of minutes as well. I'll explain a third option that you can do downstream. But once you've entered your credential information as well, there are additional options here. So I mentioned about write-time data, and Dani also emphasized about that. We may be capturing real time because it's advantageous to do change data capture. However, for Snowflake, depending on our requirements, data load, how we want to present that data, we may not want to do this real time. So we can actually put in sync frequencies in here. We can say run it every 30 seconds, 5 minutes. You can actually put a threshold in there that makes sense to you. As well as doing it from a syncing schedule, you can also control, the time zone that you want to set, the start and end times. So you may want to do this during off-peak hours after work. So you may want to set this like, for example, 1600. And then stop this, I don't know, maybe in the mornings, for example. So you can actually control when that data gets executed into the target itself. And frequency days, you may want to say this, just do this Mondays to Fridays, for example. So you have total control on how you wish to present that data into Snowflake itself. If you're using dbt, there might be a transformation you want to trigger downstream. You can actually integrate that into your pipeline in here by putting the necessary details for dbt cloud to trigger that job off. And again, we're going to enhance this in the coming releases of Estuary as well. When we update that, there will be other options in here and other solutions that you can integrate with, like, for example, Coalesce. And then again, we'll come here. I want to mention this point here. So you remember I mentioned about schema names earlier on. I want to go to a different schema name. So default option here is mirror schemas. As I mentioned, most of our clients do want a like-for-like copy. However, there are certain instances where you may want to have a different schema name downstream. So I've had to change this, and I'm actually specifying use table names only. So once this is selected, it's going to look at the schema name that I've given in my configuration here. So what you'll see downstream is a new schema. So I just wanted to point your attention to that as well, because by default, you'll see mirror schema, which will create like for like. And if I'd left it for like, it would create a schema in public. And then I will go ahead and within the materialize, I'll say, these are the collections I want to add. So again, you can be very selective here. You can say capture everything, but I'll only use certain tables. Maybe you've got different requirements downstream, maybe 2 different databases of Snowflake. As I mentioned, you can capture once, use multiple streams downstream. So you can say, well, half of these collections will go into database 1, the other half can go to database 2, for example. Or at the same time, you can do a mirrored copy of your table and a history version of your table where we've got all records, regardless, deletes or updates. So here I've specified, if I cancel this, I've specified the movies table in here. You can see it. You've also got options to publish additional columns. So there's a lot of metadata that we capture on the source. Now, as I mentioned, by default, we're going to be doing soft delete. So we've got things like op, so we can see the original op type. And we'll also have flow publish at, which will give it a timestamp as well. And then we go ahead and say save and publish. And that will also start kicking off another job that starts reading the incoming data and collections and outputs that into the target. So we can see we've got 12 records that we've propagated to Snowflake. So when we do go to Snowflake, and we'll come back here, you can see Estuary's done all the hard work for me. So we've created the movies table under demo SC. Now it's also done a backfill. I mentioned the first time you run this, it does a backfill. So I can see here within my timestamp, just earlier on, just before we started, I wanted to do the backfill. So you can see at 4:05 p.m. UK time, there was 10 records that was done as a batch job. So you can see that here. Now, after that batch job, just to make sure the demo works, there's nothing like a live demo when things go wrong, right? So you want to always make sure things work. So I actually created a new record. And you can see the timestamp here is slightly different. So that was just to check replication was working. In fact, there was two operations I did perform, and you can see here the op type here is different here. So all these C's indicates insert, a U will indicate an update. So just to show you what that actually looked like on my source when I was doing this is my change data capture script. So that's the bulk data. So change data, I entered a new primary ID 11, which was Black Panther. I did update that. So I updated the naming. And just to show this exercise, I'm actually going to perform a delete as well on that same record. So let's go ahead and execute that query as we talk, right? So that's the reason why you see 11 records, but 12 operations that occurred, because it was originally an insert and then I updated it as well. So that's why we saw a different number compared to the number of records. So that's just to illustrate there was more operations that was captured. So that's changed. If I go back into my source and I execute the script, that should change now. And that record ID of 11 has disappeared from the source. So let's go back into Snowflake. And as I said earlier on, by default, what we do is soft deletes, right? So we haven't physically deleted that record, but now we've marked it that it was marked for deletion. Now, if we wanted to change this behavior, we could have done hard deletes. Now, before I just sign off, I just wanted to go back to Estuary and mention that there was a third option, right? So let's go back into our configuration. And let's scroll down a bit. So we looked at the columns, but here, Delta updates. This is important as well. So what Delta updates does is if this is enabled, we can create our slowly changing dimension type to structure downstream. This is where you may want to create an audit or history table where, for every single transaction that we capture, we put this downstream as an insert. So even if it was an update, we convert that into an insert. Even if we see a delete, we convert that into an insert. So you will have a record for every single transaction that occurs. And when that's enabled, that's what Delta Update does, but also within Snowflake, it enables Snowpipe streaming as well. So if you're looking to stream data into Snowflake and utilize Snowpipe streaming, Delta Updates is the option that enables that. But just also keep in mind that Delta Updates also initiates a record for every single transaction as well. So hopefully this gives you a great overview of Estuary. You can see how easy it was to set up a configuration. It was a two-part process. You spin up your capture. First time you run it, it does a backfill. It takes the initial load, and then it starts switching to CDC. So as changes occur, we'll propagate that across into collections. Also, let me just go into collections and show you that there is a capability to do transformations in here as well. So I've done, like for like, I've done the E and the L. I haven't done a T in here, but we can do if we wish. You won't see Python in here just yet. It's going to be, it's one of our newest features, but it will be in our UI very soon as well. But Python is also supported. So I'm going to stop sharing now. Dani, I'm going to hand it back to you so we can close this off and answer any questions that we have as well.
All right. Thank you so much. That was an amazing demo, as usual.
Thank you very much.
Yeah, we can dedicate the rest of the time to any questions that anybody might have. So feel free to write it either on LinkedIn or YouTube or wherever you are. And also, I'm going to share this screen meanwhile, so people know where to reach out to us in case any of that seemed interesting. I would love to highlight the Slack channel that we have at the bottom. That's our community Slack. We have more than 1,500 people, I think, by now in there. So if you want to join that community, that's where Estuary folks are the most active, and 1,700 plus. Wow. So yeah, that's where we are the most active. And if you have any questions, somebody from the team can immediately answer it. So yeah, I'm going to wait a few seconds for any questions that might pop up.
So I've seen one question that's popped up. Somebody's asking their current solution, when they have new target requirements, they have to create a new data pipeline, which means creating a new capture on that same source. Is that the same for Estuary? Okay, good question. So just to reiterate, with Estuary's architecture, we have something what we call decoupled architecture. So the materialize is independent of the capture job, which gives us loads of benefits. And one of them is this use case. So I showed you capturing data from Postgres, putting that into Snowflake. In my collections, I can put a retention policy that I see fit that makes sense. With cloud storage, because it's cheap, I can put something like 1 year. Now, if I wanted to spin up a new target, just say Iceberg, I wanted to also simultaneously replicate into Iceberg as well as Snowflake. Within Estuary, I will just create a new materialization job, and I'll point it to the same collections that I'm using for Snowflake and just say replay all those transactions and put this into Iceberg. So we are capturing that data once. And again, the benefits of that from a technology point of view is that you've only got one capture job that's reading from your source infrastructure. And for those of you that look after databases, you know how key that will be to put less friction on that source. But so that's one capture, but we can use that multiple times. So we do one-to-many replication. So hopefully that answers your question. If you would like more details, feel free to ping, or Dani's mentioned that there's easy ways to contact us. We would love to talk to you in person and explain that in a bit more. But yes, capture once, use multiple times downstream.
Awesome. And I saw another question come in about change data capture and how it is different from running a batch SQL query every hour or so. Zulf, would you answer that as well?
Sure, and feel free to step in if I missed anything. But when you're using batch queries, that's very intrusive on your source database. And again, It is intrusive, but also how intrusive can that be is dependent on the amount of data that's changed over time. So typically you'd use something like a timestamp column to reference what's changed between two different periods. So that's the first thing. If you don't have that, you have to make changes to the database and you have to put a timestamp column in there. Now, again, when you do a select star and you use a where clause and you're checking, check what's changed between these time differences, we have to go into the database, do that query, and then pick up the data and move that across. And again, that's very intensive work, especially if that source database is critical to your organizational needs. What CDC does is completely different. It doesn't go to the database to do changes or change data capture. We peer into the database's logs. In Postgres' case, it's the WAR. As I mentioned, various different databases will call their logs something. Oracle call theirs redo logs. IBM call them journals. But the point is, changes are recorded in those logs, and that's what Estuary is looking at. We're going to go into those logs, and we're going to look for changes. So when we talk about overhead, we're talking about single digits of reading that data from the logs itself. And the benefit you're getting is as soon as something changes, it's committed in the database, that's the time that we will pick it up and replicate that across. So again, from an total infrastructure overhead point of view, it's still very light. So hopefully that answers. Dani, anything to add? Anything I might have missed?
No, I think that was a perfect summary of how we do CDC. Or how CDC is different. Cool. And I think there was another question that I think you touched on briefly, but maybe it's worth reiterating on how Estuary supports deletes, soft deletes, and hard deletes out of the box, and how are those actually applied on the Snowflake side?
Yeah, great question. So by default, we do soft deletes, as I mentioned. And again, just to recap what that is when we see a delete operation on the source, we don't physically delete that in Snowflake. By default, there's 2 additional columns that we do add to give more details about it. One of them is the op type. So, we do mark it to say it was deleted operation, and this is a timestamp, so it was marked for deletion, which is great. However, if you want a mirror copy of your source, so you don't want to see the actual delete operation there, you want to replicate the deletes, there is an option in the materialization job to say hard deletes. Now, as soon as that's checked, and again, you can control the columns that you wish to add. So, you can get rid of the op type column, for example. You can get rid of the flow publish at the timestamp column, and then you'll have your exact copy of the source as well. In fact, from an Estuary's point of view, there might be one additional column that's mandatory, and that's that's what we need, like most tools. But by default, from an operational point of view, delete, you won't see that. So hard deletes actually will physically delete that operation downstream. But the great thing with Snowflake as well, you've got this additional option, which is very efficient or cost-effective way of moving data into Snowflake, which is the Snowpipe streaming capability. But that's utilizing Delta updates option, which I think it was the last part that I touched on that. Now, again, that's very cost efficient, but what you've got to remember with that data point is as soon as that's enabled, what we're doing is we're creating an insert for every single transaction, which again is good. And it's a lot more efficient from a Snowflake point of view, but then you don't have an exact copy of what your source looks like. There has to be some manual intervention to actually get what the latest record is. But again, I've seen that happen as well. A lot of customers are happy with that. They just need to do some manual interventions downstream. So the great thing about Estuary is that you have a choice. The other benefit you get from Estuary is that it doesn't have to be all, one or nothing. Like I said, we've got that capability where you capture that data once, and a lot of our customers will actually create 2 separate destinations or 2 materialization jobs. One is an exact mirror copy of their source for reporting, so they've got an exact copy there. But they'll also have another materialization job where they do enable Delta updates, so they've got a historical copy as well. And the benefit is you're not having 2 capture jobs on that source. So, sorry, long-winded to answer the question, but hopefully that makes the point.
Thank you so much. Yeah, I think that's the technical depth that people are looking for. So appreciate it. You have another question that I'll actually put on the screen here. So if you have transactions every minute from 7 a.m. to 10 p.m., and I set real time, the cost of Snowflake is too expensive, isn't it?
Depends. not necessarily. Like I said, we've got a Snowpipe streaming, which is very cost effective on Snowflake. But if you're using merge queries, again, it depends on the data that you're moving. But yes, it can be theoretically. But that's when we start controlling how you want to deliver that data. As I mentioned, real time doesn't support all use cases. Dani mentioned that as well. But where it makes sense in the source, especially databases, to use change data capture, absolutely. But not necessarily downstream with technologies like Snowflake, especially if we're using merge statements and it's a lot of data, you may want to do that incrementally, maybe every half an hour, for example. So there are ways of reducing that cost. It all depends on your use case, the amount of data that you're pushing through, and what makes sense for your requirements downstream as well.
Yeah, and to add on to that a little bit, if you need that data in real time and you still want to minimize your cost as much as possible, then yeah, Snowpipe streaming is definitely worth looking into. Delta updates is definitely worth looking into so that you don't have to pay for the extra merge queries on the Snowflake side. But if you want to go even further, you can explore things like ingesting data into Iceberg and reading it from Snowflake, which we've seen customers or a few users use as a way of cost optimization. So yeah, there's a few things you can do, definitely.
That's a good point. Great point, Dani.
Cool. Those were all the questions so far, at least. If anybody has any more curveballs, then now is the time. If you can answer questions about Estuary, about change data capture, data ingestion for Snowflake, there's a lot of good topics. But if there's nothing, then it looks like we are done for the day. And I'm going to wait just a few more seconds because there's always that one question that comes in when I'm saying goodbye and wrapping up, and I'm like, no, I should have answered it. So I'm trying to spare ourselves from that, but
yeah, we could spare a few more minutes.
All right. Looks like everybody's questions are answered, so it is safe to close up the shop for today. Thank you so much, Zulf, for joining and doing the demo and answering all these questions. And thank you, everyone, for watching. And see you next time.
Thank you, Dani. Thanks for setting this up. Great session.
All right. Take care. Bye-bye.
Thanks. Bye-bye.